Let me start the second videos entitled laser. The question is, what is a laser? Laser is not anything strange. There is not anything strange about the laser. Laser is a special state of the light. Laser is not a mystery. There is not anything strange about the laser. Laser is a coherent light. A common state is thermal state. The ordinary light that shines out in a day, the light which is radiated from the sun is thermal state, which is not a coherent light. But laser is a coherent light. So I emphasize that there is not anything strange about the laser. Laser itself is a abbreviative from 5 words: light, amplification by stimulated emission of radiation. LASER, which comprise the lasers, which form the laser board. In 1916, Albert Einstein published a paper and stated the idea of stimulated emission. Stimulated emission has been introduced for the first time by Albert Einstein, which has been employed 44 years after to develop the first laser by Neyman. Generally, we know that there is three main types of transitions: absorption, spontaneous emission, and stimulated emission, which the last has been introduced by Albert Einstein. Absorption has been drawn here when atoms are in ground state and a photon interacts with atoms. If the energy of photons equal to the difference between two energy levels, photons can be absorbed and absorption transition occur. If there is no anything in the thermal equilibrium, atom can spontaneously emit the photon and goes under the lower state. In this case, atoms, when absorb a photon, atom is unstable and can emit a photon. But we have also induced or stimulated emission. Induced emission or stimulated emission are the same. In excited state, if another photon arrives and interacts with atom, it can stimulate or induces the atom to make a transition. And so we have two photons. One photon which is absorbed previously by the atoms, and another photon which has been passed through the medium containing the atoms. So we have two photons which are coherent in the same directions, with the same polarization state, also with the same frequency. Everything is the same. So this is the main idea which is used in making the laser, stimulated emission. So we can say safely about the laser that Albert Einstein has founded the basis of the laser, and after 44 years later, the first laser has been invented. Of course, I would say that for the first time, the maser has been invented. Maser, instead of L, which is light, was microwave. The first maser has been invented by ammonia gas, which I will talk about it in the next slides. In this slide, you can see a simple animation about the main processes in laser actions. This is two atoms with energy levels. So we plotted these levels close together to simulate the solid state lasers or a liquid lasers, which is the states are close together. So two atoms are in ground state, and they can pump it In laser, the atoms are pumped with electrical or with a light source, or also sometimes with a chemical energy source. So this action is named pumping. And the atoms fall in a metastable state. It is metastable state with a lifetime which is longer than ordinary spontaneous lifetime. So atoms can spontaneously emit photons with arbitrary direction, with arbitrary wavelength or polarization states, or also phase. So this is a spontaneous emission. In the next actions, we can also again pump an atom, and when a photon passes through the medium, atoms undergoes a stimulated emission. It was an stimulated emission that is excited by a passing photons. And the last scenario is absorption. When a photon passes through the medium, atoms can absorb the photon and they go toward excited states. This simply shows main process in laser medium. This is another animation you can see with a simple cartoon. This is an unexcited molecule or atom with a photon interact with it. After interaction and absorption, the photon molecule are in excited state and atom or molecule is not stable. So an unstable atoms can emit a photon and go toward a stable state. In this figure, an unstable state can also absorb another photon or interact with another photons and emit two coherent photons with the same direction, same polarization, and same phases, and of course the same frequency. In this slide, you can see the estimated emission, how estimated emission can lead to a chain reaction, and how the photons are amplified. You know, one of the word which is used in laser is light amplification. How amplification occurs? Yeah, it's an important question. So I'll show you. This is the first photon. First photon can induce atoms to the emission and so generate two coherent photons. These two coherent photons can induce us to atoms to emit more photons, and so by this reaction the photons are multiplied and light is amplified. So amplification of light is performed due to stimulated emission. Okay. Another important event which has happened in a laser medium is population inversion. What is population inversion? When the population of an excited state atoms is excited state in a medium is larger than the population in the ground state, we can population inversion has been occurred. So excited excitation of atoms can lead to a population inversion. I will show in this animation how absorption can lead to an excited state or vice versa. You know, in our ordinary states, the population is not population inversion. Atom can absorb photons, and so the light is attenuated. But in a medium that we have population inversion. In other words, the population of atoms in the upper state or the excited state is more than the ground state. If a photon is passing through the medium, the light is amplified by relaxation atom from the excited state to ground state. So, depending on the population, which is direct population, ordinary population, or inversion population, the light passing through the medium can be absorbed or attenuated or can be amplified. But the main question is how we can produce an population inversion. We have two types of lasers: 3-level lasers in the left hand side and 4-level lasers in the right hand side. In 3-level lasers, at the first stage, we pump the atoms from the ground state to the E1 level, or at the pumping level. What is this process? Pumping. Okay, this is a very fast relaxation. Atoms pumped to E1 level and does a quick relaxation. After that, a passing photon can stimulated atom to undergo stimulated emission, and the laser occur from this transition. Also, this is a 4-level atom. From the ground state, atom is pumping to the E1 state. This is a fast relaxation. This is a stimulated emission, and again fast relaxation. The main question is how we can produce population inversion. For a 2-level atom in an thermodynamic equilibrium, we cannot produce population inversion. In a normal situation, you cannot populate the upper state more than ground state. So we need more states to do that. In 3-level state, we need one state with a quick relaxation, and in the 4-level atom, we need E1 and E0, 2 more states to do that. So see again, this is pumping. This is pumping very fast. So at this moment we can produce in population inversion. In 4-level laser, we use pumping, fast relaxation, population inversion. We can have population inversion. Or you can compare the situation with 2-level atoms that in that case we cannot produce population inversion. So we need at least 3 or 4 levels. So we can categorize lasers from the number of levels engaged as 3-level lasers, 4-level lasers. We have not 2-level lasers at all. It's not possible 2-level lasers. So let me finish these videos due to a large amount of size, and I continue the lesson in the next video.